Hey everyone, I'm making this short video to demo the voice and vision AI features of Ubo Pod. I'm going to create another separate video for non-AI features to keep this video short. So what is Ubo Pod? Ubo Pod is an open source hardware and software platform designed for developers and makers. The goal is to empower developers and makers by giving them a set of polished tools to make interactive AI-enabled applications. So these applications can use voice and vision to create multimodal user experiences for the end users of developer applications. Before I get into the demos, I want to give a quick overview or a table of content for what I'm going to talk about or show in the video, and then we're going to move into each item one by one. So I'm going to start off the video by giving you an overview of the setup procedures, how you can set up different services or how the first time experience looks like after powering on the device. And then I'm going to show different trigger mechanisms that you can use to trigger the AI assistant on board. I'll show a multi-turn conversation, and also after that I'll show a multi-language demo. I'm gonna show a use case for tool calling. I'm gonna use web search for that. And after that I'm gonna show a demo of image understanding. So this device has a front camera. We're gonna use the camera to look at something, and then the AI is gonna tell us what it sees in the picture. And after that, I'm going to show a demo of image generation. We're going to ask the AI service to create an image, and we'll show it on the LCD screen. And after this, we're going to go through some examples of short commands. So you can actually have shortcuts with voice to enable and access some features on device. And after that, I'm going to go through a fully offline demo that will run the large language model and all of the AI stack on device. And at the end, I'm gonna talk a little bit about our kind of future work and long-term roadmap, or the things that we want to do. That's gonna be it for this video. So let's just jump right in and start with the demos. So when the device powers on, you're gonna see this graphical user interface. So this is what you will use to control different settings on the device. For example, you can control the volume level with the buttons here. And at the bottom, you can see different status icons, if the microphone is on or off, if the Wi-Fi is connected or not. And then if I go to the menu, you have different options here. You can go to the settings. And here I'm going to scroll down to the assistant setting because that's something I want to focus on in this video. And here we can set up our AI pipeline. So what does that mean? So when you interact with an AI through voice, usually in the first stage, your voice has to get converted into text. So you need something like a speech-to-text engine or a speech recognition engine. So the first setting here is for speech recognition. And here you have multiple options at your disposal. So you have VOSK, which is an offline speech recognition engine. It runs fully offline on device. It does not require any internet connection. And then you have options for Google speech-to-text, OpenAI, and DeepGram. So for the first demo, I'm going to choose DeepGram. We're going to permutate between different services as we proceed in this video with the demo. And then the next stage of the pipeline is a large language model, where the model takes text or images as input and outputs text. So here we have an option for Ollama for running the model on device or offline on-prem. So basically, at the end of the video, I'm going to show a fully offline experience running the full stack on device with Ollama Quinn model. We're going to get to that. And then we have support for Google Vertix, which is Gemini basically, Grok, Cerebrus, OpenAI, and Anthropic. So for the first demo, I'm going to choose Cerebrus, and then we're going to switch around to different services. So let's go back to the options here, and then we have speech synthesis. So when the text is out, you have to read that back out to the user. And for this, we have multiple options. So the first one is Piper. Piper is fully offline. You can run it on device with no internet connection. It sounds a little bit robotic, but I think it's just fine. And then we have Google, OpenAI, ElevenLab. With ElevenLab, you can have custom voices. So you can have, like, this is very useful for storytelling use cases where you want to have different characters in your story, use different voices. And you can also do voice cloning and have cloned voices. So it's pretty handy. In the future, we're gonna allow options for ElevenLab to switch between voice IDs and voice, so you can pick different voices. So right now you just check the engine in the UI. We don't have an option to switch between voices, but we're gonna expose that down the road. And the other thing is that this is a fully open source product, and developers can go and contribute to this. And if you think you want some feature, you can actually open a pull request, and if you're going to review it. And we really would love to have participation from the community to extend the features of the core software. So, and then the fourth option is image generator. So image generator support here includes Google and OpenAI. So these engines will take text and then they will output images. Yeah, so that's it. Let's just get into the first demo. So in order to talk to the device, you need to trigger the assistant first. There are different ways you can trigger this. One is by holding down the home button. The other option is to use a remote control like this one. So this is an infrared remote control for my Samsung TV. And then this one, I have mapped the record and the stop option for like talk and stop. So you can hold this, like press record, talk, and then when you're finished, press stop, and then the assistant will respond back. We can map more buttons here. It's just we have IR receive functions on device, which is very handy for mapping different triggers to a remote control. The device can also blast IR. So these are non-AI features that I'll go through in a separate video. So let's start with just the home button right now, and then we'll try the IR next. Let's ask a simple question. I'm going to New York City next month. What are the top 3 places I can visit while I'm staying there?
You can visit the Statue of Liberty, Central Park, and the Empire State Building. These iconic landmarks offer a great mix of history, nature, and skyline views.
So you can also ask follow-up questions. It keeps the context. So I can say, what if I were to choose one? Which one would I choose?
Central Park. It offers something for everyone, from scenic walks and boat rides to people watching and quiet relaxation, all in the heart of the city. It's especially enjoyable this time of year.
So you can ask follow-up questions, and it keeps the context, so it really knows what you're talking about, unlike other assistants that you use like it's like a one-time interaction. And then we're going to get into the memory management. You can keep a long memory of conversations on device, and then it has like you can basically pull context from old conversations and then resume those conversations. But now let's just move on to a multi-language example. So I'm going to go here and switch the assistants for this one. I want to make sure that they support the languages that I want to interact with. So for the speech to text, we're going to choose OpenAI. So we're going to go full OpenAI stack for this one. And then we have the OpenAI here, and speech synthesis, OpenAI. So we're on OpenAI, full OpenAI here. Okay, let's try a multimodal example. Estoy pensando en viajar a la Ciudad de México. ¿Cuál lugares me sugieres que visito?
Lugares para visitar en Ciudad de México incluyen las ruinas antiguas, edificios con valor arquitectónico, castillos, cementerios, centros cívicos, lugares religiosos, lugares educativos y fuentes. También puedes disfrutar de los hermosos jardines, la arquitectura única y los canales de Xochimilco.
So I'm gonna try something in Farsi. I'm gonna ask what countries speak Farsi. مردمان چه کشورهایی به زبان فارسی صحبت میکنند؟ Let's see if I have this set up correctly. Oh, sorry, yeah. I made a mistake. So DeepGram does not maybe it supports Farsi, but I should have selected OpenAI for the speech to text for Farsi. Let's try again. مردمان چه کشورهایی به زبان فارسی صحبت میکنند؟
ایران، افغانستان و جامائیکا به زبان فارسی صحبت میکنند.
Yeah, so for multilingual support, you have to make sure that your stack, your full stack, supports that language. So that means your speech-to-text, LLM, and also text-to-speech engines should support that language. Let's go to the tool calling example. So we can actually do tool calling, and basically for tool calling, I have set up a Brave Search MCP, which is basically you can do web search, and I'm going to use that for the demo. We are planning to add support for just to give this option to developers to easily set up different kinds of tools and enable and disable them as they wish for different engines. But right now, this is kind of hard-coded, and there's no way to disable and enable that through the menus. But you need to bring your API key for Brave Search MCP. Let's try something. Let me just double check if we got the correct setup. Language model, OpenAI. Yeah, I think we're good. Let's do, what are the top 3 news stories that came out today?
The top 3 news stories for today. 1. Romania says Russian drone incursions pose new challenge to Black Sea security. Romania's defense ministry condemns the irresponsible actions after a drone entered its airspace. 2. Far-right groups dox online critics after Charlie Kirk's death. Right-wing activists target teachers and workers for critical remarks on Charlie Kirk's death. Who is Tyler Robinson, the suspect in custody for shooting Charlie Kirk? The FBI identifies a 22-year-old man from Utah as the suspect in custody for shooting Charlie Kirk.
So as you can see, it will search the internet and it gets that result and it read it back to you. And it's a very handy tool. You need to get an API key from Brave for doing that search. Now let's move on to the image understanding demo. For this one, I'm going to use Google Vertex, which has a better...
Any more questions or need further information, feel free to ask.
So I switched to Google Vertex for this one. What do you see? So I have a Raspberry Pi. I'm going to show it to the... So it's going to ask for camera permission, and I'm going to hold this in front of the camera.
Someone holding a Raspberry Pi.
Yeah, as you can see, the image also shows up here. You get a preview of that. You can zoom in and scroll up and down. Yeah, so this is, you can do image understanding, show something to the camera and ask a question about it. You can extend on this foundation. You can have kind of like bring that into your conversation context and ask follow-up questions. And it's just kind of your imagination and your skill sets or the limit really what you can do with this. So let's move on to an image generation example. Let's try an image generation. Create an image of a dog and a cat dancing together.
image generator is creating a picture of a dog and a cat dancing together.
Let's see, it should come up here. Yep. So I can zoom in here at this one, as you can see. So yeah, this was an example for image generator. What else we have here on our list? I want to show you some voice shortcuts. These shortcuts are very handy when you want to access something quickly, and they don't really use AI. It's just like the rule-based. You have to provide some options for rules. Let me try that. Short voice command. Turn up volume. Turn volume up. Yeah, so this one, like you have to enumerate different kinds of options. I didn't enumerate this one, but it's kind of like basically string matching or regular expressions on the things that you can say, and this runs fully offline. Let's try short voice command. Turn volume down. As you could see, this goes up and down. There are a whole bunch of other features that you can use. Let's try something else. Short voice command. Create wireless connection using QR code. Create Wi-Fi connection using QR code.
Go to your phone settings, choose QR code and hold it in front of the camera to scan it.
I said it wrong the first time. That's one of the challenges with these like kind of short commands. They have to match exactly what is kind of on file. And for this one, you select the camera, and then you can hold the QR code. It scans it for connecting to Wi-Fi. All right, let's go back and do a full offline demo. So I'm actually going to go to the settings here and then disconnect Wi-Fi. For this demo, I'm gonna go like select Wi-Fi here and then press disconnect. And then as you can see here at the bottom, the Wi-Fi is disconnected. And then I'm gonna go here to settings, assistant. Let's choose VOSK and then go to language model, select Ollama. Let me zoom in. Let's select Ollama and then let's go back to speech synthesis and select Piper. So now we have like a fully offline assistant setup. I'm gonna go ahead and ask a question with the fully offline setup. So I have Ollama already set up here. As you can see, the Wi-Fi is disconnected. I'm gonna zoom in on the screen. Wi-Fi is disconnected, and I'm gonna start with the conversation. Can you tell me a short history of Mexico independence? So as soon as I ask a question, the model is going to start loading into the memory. So you can see that the model is gradually loading into the memory, and the memory usage is going up. So this is a Quinn 2.53 billion parameter model. It's probably like too heavy to run in Raspberry Pi 5. You can run smaller models like Gemma 1 billion parameter, but I chose this because it has tool calling capabilities, and there was an issue that if the model didn't have tool calling capability, we ran into some errors, but I'm gonna fix that so that we can run smaller models also on device. And tool calling means like when you say when you talk to the device and ask, for example, what do you see in the camera, it knows that it has to use the camera tool or to call different tools, basically. So the first time you ask a question, this is gonna take probably around 20 seconds or 25 seconds to answer, because first it needs to load the model into the memory, and then there's like a time to first token. So it takes a long time the first time you ask a question, but the second time it's going to go down to about 5 seconds, as long as the model is loaded in the memory and kind of primed to give you a response. So let's give it a little bit of time. So to have a better offline experience, I highly recommend hosting your Ollama model on a different computer.
In the late 18th century, Spanish colonial rule in Mexico began to face increasing resistance fueled by social inequalities and economic hardships. The period sparked calls for independence that culminated in the Mexican War of Independence, which started in 1810 when Father Miguel Hidalgo y Costilla issued the Call to Arms manifesto calling for an end to the Spanish rule. 1821, after years of struggle and battles between revolutionaries and royalist forces, the Treaty of Cordoba was signed, declaring Mexico's independence under federalism. The moment in modern Mexican history marked the official beginning of the Republic of Mexico on September 27, 1820.
So as you can see, the CPU usage has gone down, and I can ask another follow-up question, or yeah, so this time I'm going to use the IR remote. I forgot to use it throughout the demo, so I'm going to press record talk and then press pause to stop talking. How many states are in Mexico? This is going to respond faster because the model's loaded, probably 5 to 6 seconds. Still a long time for having like an
states in Mexico. And not a federal state with multiple states. 31 states and 1 federal district, which is the city of Mexico.
Yeah, there is a problem when the CPU maxes out. Also, the text-to-speech gets choppy. So I highly recommend running Ollama on a different machine, or at least run a smaller model and on Raspberry Pi 5, and that way you can have a way better performance. So if you have like a machine with GPUs or something, you can even run it on a mini PC. If you have enough memory and a good CPU, you can run larger models or mid-size models on powerful mini PCs, and then you would use this device just like to do text-to-speech, speech-to-text, and this will use the API hosted on the other local machine. So what else do I have on my docket here? I want to show you something on the ElevenLab speech-to-text, text-to-speech, sorry. I'm going to go to network, connect back to Wi-Fi, select my Wi-Fi network and connect back. And then I'm going to go back to settings, assistant, and then I'm going to switch the models. Let's keep this as VOSK. Let's use the language model to be OpenAI. Then let's go use ElevenLab for the speech synthesis. And I made this like funny mouse voice. So I want to show you this. Can you tell me a short history of Disney?
Disney on October 16, 1923. It began as a small animation studio and grew to become one of the largest and most well-known entertainment companies in the world, creating iconic characters like Mickey Mouse and producing beloved films and theme parks.
So you can actually go to ElevenLab and prompt for a special voice. This was like a little mouse voice, so you can have different ones. It's quite fun. You can play around with different. You can also clone someone's like voice with their permission, of course, and your own voice, and then use that as kind of the default speech to text to speech. What else do I have here? I skipped one step during the setup overview in order to get to the demos quickly, but I would like to take this opportunity and show you how you can set up a service that requires an API key with the graphical user interface and the web UI. So you do not need to SSH or access the terminal in order to set up any of these services. So I'm going to walk you through setup process of Grok, for example. So if a service is not set up, we show a gear icon next to the service name, and that means the service is not set up. If it's already set up, it shows a checkbox, and that allows you to select that service. So I'm going to go ahead and select Grok and show you how we can set up the API key for Grok.
You can use either web dashboard or camera to enter this input. Please choose one by pressing one of the left buttons.
So there are two possible ways to enter the API key for the selected service. One is through a QR code. So you can basically take the API key, convert it into a QR code, and then press this button. It'll open the camera and you can scan that QR code to pass the credentials to the device. The second method is to use the web UI, which is the one I'm going to choose and demo right now. And so I'm going to go ahead and select this one.
Please make sure you are on the same network as this Ubo Pod and open http ubo0z.local:4321 in your browser.
So this basically, to enter the API key through this method, you go to this address here. So I'm going to go on the browser and enter the address ubo-z, ubo-0z.local. :4321. So that's the port number. And then as you can see here on my screen, it is waiting for me to enter the API key. So I'm going to go to my Grok account and then create a new API key. I'm going to call it demo, and then it's provisioning the key. Select the key, come back here, enter the API key and press provide. And then we emulate also the graphical user interface inside the browser. I can go ahead and select Grok here on the browser and it'll select this service. So it's very simple and you don't need to access the device via the terminal or anything like that. You can just do that through the web browser, through the web UI. So after setting up Grok, I'm going to ask you a quick question to make sure it is set up correctly. What company has developed the large language model that is powering you?
Powered by Grok, a large language model developed by XAI.
So let's talk about the long-term roadmap and what we have on our stack of to-do list for the future. Before I get into that, I want to emphasize that this is an open source project and we would love to get open source community developer participation to help us in expanding these capabilities. So the code is on GitHub. You can go and contribute to it, make pull requests. Even for the features that are not on our roadmap, you would consider including them in the core functionality if it's something very interesting. But outside of this, you can always write your own sandbox applications that communicate with the core, so that your code does not necessarily have to go into the core of the application and it can communicate with the core application. So it really depends what those features are, and they don't necessarily need to go into the core of the application. So the things that we have in mind for the future is to add some extra options here under Assistant. One is the tools option. So we would like to allow people to easily bring and add different MCP servers. So imagine we're going to have a tool option here, and then you go here and you can add an MCP server that can be a local, basically server running on the device with Docker or NPM, or it can be a remote endpoint that you just bring your endpoint and this is going to communicate with a tool running on a remote machine. And so we would like to add some UI for bringing, MCP servers and tools for tool calling functionality. The other thing that we have in mind for the future is audio understanding. So I showed how we can show something to the camera and then ask questions about what the device sees. We can do the same thing with audio. Basically, we can have certain triggers. The device would listen to the audio in the surroundings, and it can tell you, I hear some dog barking, and or some people are arguing in the background or whatnot. Like, these are kind of audio understanding beyond the verbal speech. And then we would like to have some sort of like trigger filters for this. For example, if there's a motion detected in camera, it triggers the vision assistant, and it would take some video and then send the video frames to the LLM for deeper analysis and understanding what it sees in the video frames. And we can do the same thing with audio. We can have some sort of audio activity detection if there's increased amount of noise level, or if it listens to a lot of people talking for a sustained amount of time, it can trigger something. So we can actually set up these triggers, and then it would have a second stage that the large language model would take audio or video as input, and then it will give you an explanation on what it hears in the audio, or you can have more specific questions about what is in the audio and the video. So that's audio understanding. And on the hardware side, we would like to add support for AI accelerators. So there are two types of accelerators. One would be like Google Corral. That would be ideal for kind of more classical machine learning applications like motion detection or video segmentation or object detection or things like that. And this is a Google Corral, and this is an adapter board that we've designed. It goes inside the device, and it allows you to plug in an AI accelerator of this type. And we have our eyes for AI accelerators that we can use to accelerate AI operations, like the LLMs on device. And we're talking to a few companies. There are not many options out there right now, but I think in the next couple of months, maybe 6 months, we're gonna see very interesting options in the market for AI accelerators for LLMs. The third thing that we have on our plan is making voice satellites, so you can have multiple of these devices in different rooms, and then one device will act as the main hub, where it has all the API keys, or acts as a hub basically, and then the other devices simply send the audio to the main device and act as voice satellites. This would be ideal for kind of a multi-room setup. And the thing is that you can have a less powerful device running on a Pi 4 with less amount of RAM and a lower cost as a voice satellite, and your main hub will be a Raspberry Pi 5 with more memory and so on. And you can also have another powerful device that runs the LLM, and then this would run just a speech to text or text to speech. You can also run those on another machine, but we can have kind of this distributed architecture that you can have a hub and multiple satellites, and the hub itself receives audio from built-in microphones. So that on the software architecture side, this thing is already in place, but we need to figure out the UI part. How do we do the pairing? How can you tell the hub which nodes are the satellite and how you set it up? So we need to do some UI work to make the onboarding of satellites easier. I am basically planning to launch a Kickstarter campaign to bring a set of these devices to market. We have done some pre-production work and made several of these devices that are in hands of beta testers, and we're excited to bring this to market, to get this in the hands of more developers and makers and see what they would like to do with this kind of device. And if you enjoy these type of projects, We would really appreciate if you support our Kickstarter campaign. I'm going to include a link in the video description, and if you follow our campaign, we're going to notify you as soon as it launches. And if you are coming into this with little technical background, you can still use this device. But we kind of expect that you understand a few things. For example, you have to bring your API keys. You have to sign up with some of these services as a developer and then get API keys. So if you have done that before, if you have signed up with any service that gives you an API key, you should be able to set up the functions on this device. But if you have no idea what API key is, it might be a little bit challenging to use this device. I really appreciate your time watching this video, and if you have any comments, please do let me know in the comment section, and I look forward to hearing from you. And if you like to see the part 2 of the video, subscribe to my channel, and I'm gonna publish that part 2 in the next week or so.